Hello and welcome to Source to Code, your magic decoder ring to demystify the jargon surrounding the technology industry. I'm your host, Ben Coffin, and join me each week as I try to dig into what these buzzwords are all about, how they're being used, and who might actually need them. Today I'm continuing my journey into the world of artificial intelligence in part 2 of our AI series. If you missed last week's episode where I talked to Rahul Brito, who's a PhD student at Harvard University, who's using AI to analyze the human brain to predict mental illness, zip on over to keysight.com/find/source-to-code where you can check out that episode. While you're there, sign up for our mailing list so you can stay up to date with the latest and greatest from Source to Code. And if you join our mailing list, you could be eligible for a giveaway of some Source to Code swag. You can also find content connected to each show topic to take the decoding into your own hands and dig deeper into the world of AI, digital twins, big data, and the metaverse. This week, we've got a white paper called New 6G Challenges Inspire Cross-Disciplinary Innovation. New technology for the 6th generation of wireless comms is on the horizon, and that means that these ideas like AI and machine learning have to come in from other areas of technology to help us move towards the next generation of wireless networks. You can find this white paper and all things Source to Code at keysight.com/find/source-to-code or through the link in our show notes. Now, on with the show. Wireless communications is something that, when it works, we don't notice at all. I use my phone and laptop for work all day, as I'm sure a lot of you do, and I'm switching between Wi-Fi and cellular as I come and go from my home office, and for the most part, it just does what I want it to do, which is connect me to the internet. And when it doesn't work, it's the only thing I notice. Think about it. You're disconnected. You're marooned from the rest of the world, frazzled because your call dropped or your download failed. At the end of the day, wireless comms is a fabric of technology that makes our everyday lives possible. So where does the AI come in? As I kept pulling on that thread of AI, I wanted to see if I could put it into a context a little bit more familiar to myself after this conversation with Rahul on last week's episode. My day job at Keysight is working on marketing for advanced wireless communications. And so this is a space that I know. This is a big part of what we do at Keysight, and it's just what I've spent most of my career working on. But AI is fairly new here. It's only really being used in communication protocols and management of the network in the past couple of years. Now, that's not to say that AI hasn't been researched and tried in comms, but the widespread adoption is kind of just still happening. Cellular communications especially have relied on hardware-based systems back in the days of 1G and 2G, and as these networks are starting to evolve, they're becoming more and more software-based, especially in the networks of 5G today and beyond. And so as that software interface and software capability expands, AI becomes a logical tool to add to that development toolbox. So to learn more about how AI fits into the wireless toolbox, I decided to reach out to Sarah LaSelva, who's our director of 6G marketing here at Keysight. I wanted to get an idea from her about where AI fits in the 5G story today and where it might take us into the future. We'll be right back with my conversation with Sarah right after this.
Hi there, I'm Daniel Bogdanoff, host of the Keysight podcast Double E's Talk Tech. Basically, when I'm at the office and overhear an interesting conversation about a new technology spec or application, I rope that person into being on the podcast. So you get an insider's look at the latest engineering trends and technologies from the people that are actually defining the specs, like USB, PCIe, 5G, SATCOM, metrology, and I'll even call in an occasional YouTuber friend like Mehdi from Electroboom or Shahryar from the Signal Path. I don't care what Ben told you about me. Come check out Double E's Talk Tech. That's EES Talk Tech. Wherever you get your podcasts, I have a fresh lineup for 2023 that you won't want to miss.
Well, thanks, Sarah. I appreciate you hopping on to talk with me about AI. So I had my first conversation about the use of AI and sort of some research and as a data tool. And now I'm trying to contextualize it a little bit more to an area that I know a little bit more about, which is wireless communications. So I'm really curious from the wireless world, cellular devices and all of this, like what is the role AI is going to play in our wireless networks?
Sure. So good question to dive in on. AI, as you know, or maybe don't know, but it's really good at solving problems where there's a lot of data involved and it can kind of be based on pattern recognition.
Hmm.
And so anytime you're trying to solve a problem that maybe humans aren't good at, AI might be a good answer. And so one of the areas where AI can really help us with wireless is the general topic of optimization, right? If you think about how do I optimize something, there's a lot of different inputs and a lot of different number crunching that kind of goes behind it to get an output on the human side. Whereas AI doesn't necessarily need that. You can feed in a bunch of good training data and it can come out with something with a lot less compute power necessary. So, in my mind, optimizing our wireless systems is where it's going to play. But what does optimization mean? Well, it can mean just about anything. And the wireless ecosystem is so rich in different applications for where AI can fit. I think it's going to be everywhere, and I don't think that that's really an exaggeration. Um, to give an example of that, what we're seeing today is people are already using AI to optimize the design of things in the air interface. So this is optimizing some of the base algorithms that run inside of your handset, inside of the base station today. So
Got it.
let's take decoding and encoding, for example. To send the signal over the air, we run some coding algorithm on it. On the transmit side, the receive side has to be able to decode that. And we have encoders and decoders that have been around for a long time, and some of them are pretty efficient and some of them are less efficient. And so AI
Mm,
is looking at saying, how can I optimize those algorithms to make a more efficient version of coding? So that's one area, and AI is working on doing a lot of those different blocks. But you could also look at AI as solving an optimization at an entire network level. Energy efficiency comes up a lot as a topic that we want to make our wireless ecosystem more energy efficient. And with AI, we have the ability to kind of take a step back and look maybe at an entire nationwide level of how is our energy usage? How do I maybe pick which base stations have the highest load versus which ones that don't? You could also take that down a level and say locally, okay, well, so Ben and I are based in Austin, and maybe within our neighborhood, we could be covered by multiple different base stations. Well, is there a way to optimize how that traffic flows to each of the different base stations to use one of them, maybe even just turn one of those base stations off and we can handle
yeah.
it with only one instead of two? And then you can even take it a step further and say, within the base station itself, what processes are running and how can I perform optimization? Can I turn certain pieces on and off? Like RF power amps, for example, are really power hungry. And so
Right.
anytime we can turn off an amplifier, that's a great way to save energy. So all of those kind of ideas are starting to play out. We're already starting to see those in wireless today. And I think looking into the future, it's just going to be that on steroids, where
Mm.
anytime you can stick AI into the system, there's an opportunity to let it optimize and make our wireless devices, our wireless communication, just even better than it is today.
That's really interesting because I think, maybe the first thing that comes to mind, like when I thought optimization of the cellular side of things, is maybe like coverage and just like because like, I think personally we all sort of reference either like do I have bars or what does my speed test say as sort of our like own personal metric for like is my cell service good. But it's interesting to think about like when you get to this point, and we're very close there, especially in urban areas where like service is just uninterrupted. Like you just have service in like most places. It's then a optimization of, hey, well, we can actually optimize the back end so that we, don't have like what you were saying about the power efficiency. Like we can just turn that tower off when it's not needed because we have reached the coverage like position that we want to be in. Yeah, that I think is like I thought handset first, but network first makes a lot of sense.
Yeah, absolutely. And energy is efficiency isn't the only thing. We're trying to look. on the energy side, it's how do we make things greener, more sustainable? But
Hmm.
there's also other non-renewable resources that we're using with inside of cellular communications. And the most scarce resource that we have is spectrum.
Oh,
We
yeah.
can't get any more spectrum. We're pretty limited there. So looking at ways to optimize how the spectrum is used is an area where AI can have a huge value for wireless in particular.
Yeah. Yeah, it's the spectrum thing is, you like see these sales of spectrum where it's like, billions of dollars for a piece of spectrum, and like it kind of feels sometimes I think like I'm like, what does that even mean? But it is this finite resource, and I think you like positioning it that way as a finite resource is really key. Is that like there's only so much of the air frequency for us to go around, right? And we're pretty capped on that front. That's really interesting. So, okay, let me play devil's advocate a little bit. Do we need it to be AI? Like, I think about in my last episode, AI is a tool. I've learned that AI is a tool, and it's something that can. And you even said it at the beginning, like it's really good at pattern recognition. It's really good at these like specific things. But it is it a must have, or is it a I don't want to say like get out of jail free card, but is it like the easy way of doing things? Like what's the requirement?
So I don't think I would ever say that AI is the easy way of doing things.
Okay.
It's maybe the trendy way of doing things.
Interesting.
AI is certainly a buzzword, and if you look within academic communities, people trying to get grants and things like that, AI research is hot right now. So yes, AI is the trendy way, but it's a great question of do we need it? Does it make things better? And the answer is I don't think we know yet. There's
Okay.
some applications where like doing the full level network optimization, I'm going to go ahead and lean in and say, yes, we need AI to do that.
Hmm.
Humans have been trying to do that and we just don't do it well. But the other example I gave about the decoders, there's actually some really interesting research going on from a professor at MIT where she's looking and saying, okay, let's maybe not use AI in the decoder. Let's look at making a universal decoder and
Mm.
something to where we can have
Oh,
all of this technology on a chipset and design that chipset smarter to where that chipset is using less resources. And how can we use that instead? This idea, this universal one. And she's looking at some really smart ways for the manufacturing and building of this. And the results that she's getting are the same as they're seeing with these AI optimized ones. And
hmm,
that gave me a pause because it's really interesting to think about that of kind of universal and using what we already have, because then you get this really nice backwards compatibility as well. If we're not going to lose older devices anytime soon.
right.
There's always the people who have the older things, or some devices just aren't meant to be replaced every 3 to 5 years, like a handset. For example, a lot of cars these days have 4G built onto them.
Right.
What does that look like in 10 to 15 years? Because I do think that those cars will still be on the road. So, backwards compatibility is something interesting to think about. And there are a lot of novel techniques that we can do to improve efficiencies of wireless that aren't necessarily based on AI. So I would challenge the industry to really think about, is AI going to add value here? There are absolutely places where it will, but there's also places where it won't.
Yeah, and that is the like I think coming in as I've started these conversations around AI is that I sort of saw it as this like one size fits all solution where, I think some combination of like what science fiction has taught us that AI is versus just sort of the like the buzz, right? The just like straight up buzz about AI. There's like it seems like it can solve all problems, and then you dig into like what does it actually do, and it's like, well, it doesn't solve all problems. It can just solve a very specific problem that you train it to do. And so that's I think some of the like disconnect that maybe some folks have when they think about AI is that they're like, well, I thought it was going to solve everything, but it actually only solves this one really specific thing. And so it's sort of balancing expectation with reality a little bit.
Well, and there's also the maturity of AI to think about too. Um, if you look at what are some of the more mature applications for AI, facial recognition or image recognition is a great one that has a little bit more maturity. There's been just so much work being done by, kind of the likes of Facebook, Amazon, Google, all
Hmm.
looking into this. But when I go back and I review my photos in Google Photos, and there's great search, photos of my dog still get tagged as a cat.
Yep.
Right.
Exactly.
So even kind of in this more mature area, we still have issues, and there's issues of bias as well. And bias in a facial recognition algorithm looks really different than bias in a wireless communications algorithm.
Mm.
But it's certainly something that we need to be cognizant of when we're designing these systems. And again, just recognizing where we are in the process, adding AI to wireless. In some areas, we actually have pretty good algorithms that we can use immediately, but others, we're 5, 10, if not more years away from being at a point where it's stable and it's reliable.
Interesting. Okay, so then maybe help me get a sense of like if I today, right? I've got an iPhone 12, I've got a 5G chip in it. I'm getting 5G service. What is like talking about where we are today? What is AI doing in our networks, right now? Like when I look out my window and I see this cell tower, what is it where is its AI happening?
So where we're seeing it right now is on some of the design side. Like I said, there's some good algorithms to help with the actual like RF front end design and doing some optimization there. We're looking kind of, I don't know what release it's going to be in for the 3GPP releases, but there is work in like release 17, release 18 to start adding AI and to optimize some of the air interface.
Hmm.
Um, but kind of that's about where we are right now for AI and wireless. Another area that's really interesting that's just starting to take off is looking at doing system level orchestration or intelligent control of the RAN. Within the Open RAN ecosystem, there's this idea of a RAN intelligent controller where
Hmm.
you can run apps on top of that controller and you can use AI in those apps to do optimization. And so that's a really nice kind of use case. So we're still a couple years out from deploying Open RAN. There are some initial deployments, but we haven't seen the overall kind of transition
Got
that
it.
we were expecting. We are, however, seeing a big transition to more virtualized RAN. And there are still things that you can do that don't necessarily need this RAN intelligent controller from that's in the Open RAN version to start looking at using AI for optimization. And a lot of that optimization is coming into that power efficiency area that I spoke about earlier, turning things on and off within a base station to really drive down the cost of watts per hertz. This isn't a new problem. The ecosystem has generally been aware that they use a lot of electricity. So we are a little bit further ahead in that area than some of the other areas where AI might be able to play in the future.
Yep. Okay, that makes sense. I think yeah, the sort of like orchestration that you described, like that makes a lot of sense. If I think about like um we got a soccer stadium here in Austin. Everybody shows up to the soccer stadium for the game, and like we think about like 5G was touted, I think, a lot for being something that was going to solve that sort of problem. I have to imagine there's a lot of like orchestration type stuff that goes into that process of like, hey, all of a sudden a ton of users just showed up in this one cell. So that being on the cusp, I think, still makes a lot of sense because that feels like a very like I don't know, still present problem.
Yes, absolutely. It's still present. And you're also right, it's on the cusp. And that is a fantastic use case where AI can really help with our networks and our communications.
Very cool. So next, right? Like, so you said 5-10 years down the road. Like, what's we talked about design, and I think design obviously opens the doors to like, oh, okay, so it's not just going to stop at 5G. It's not going to stop at the next release of 5G. Some of this maybe 5G advanced stuff, like we saw with LTE. Is there a bridge that AI is building to get us to the next thing? And if so, what is that?
So I don't know if I'd say that there's a bridge, but it's more just that it's continual evolution.
Mm,
And you can look at it if you think about a wireless network. Let's talk about 5G release 15, the first version of 5G that was out. And the previous versions of cellular before it. if you just take the air interface example, on the transmit side, you have a couple blocks that include your encoding. And on the receive side, you have other blocks that include things like decoding and symbol demapping, things like that. So we have those individual discrete blocks. The first step that we've started to see and that I've mentioned is we're optimizing those individual blocks using AI.
Mm-hmm.
The next step that we're going to start to see is, okay, so now can we optimize multiple blocks together? What if we want to look at a bigger part of the signal chain? And really specifically, this work is being done on the receive side. So how do we take multiple blocks, kind of combine them together and say, all right, AI, here's your set of inputs and kind of expected outputs. Figure out these things that we may have done in 3 steps before and do it in 1. Now, if that were to continue, the real moonshot idea for AI that could be in 6G, could be beyond 6G, is what if machine learning designed the entire physical layer by itself? What if we had a block that was a transmit block that's completely void of human design? And what if we had a receive block that's also void of human design? And that gets really interesting because then, I'm skipping ahead here on what the technology can do, but if you think about it, you could have your wireless protocol optimized for a specific handset and the performance and linearity of the amplifiers on that handset and the performance and linearity of the amplifiers on that base station. You could have the waveform itself optimized for the environment. That waveform could change if it's raining or, if there's buildings in the way and the building can reflect the signal in a certain specific pattern that's advantageous. AI could adapt the waveform based off of, where that specific base station's formed. So it gets really interesting when you start to think about if you're optimizing the entire thing and you can do it on this hyper local, hyper specific scale that you certainly couldn't do if you had just a fixed algorithm and fixed ICs inside of a device.
Yeah, that's nuts. I hadn't even considered, I think, the extent of that. When I think about, my phone trying to get service, I just think it's broadcasting at full blast and just help, please let me get some bars. The idea that it could be so tailored to even your specific handset itself and your all the parameters that it could change how it's interacting over the air. I think the bonkers thing to I totally see the logical progression of that. I think the bonkers thing for me to wrap my head around that is science fiction feels is the how do you if a computer created it, how does the next computer know? And this is what's so cool about the potential of AI, I think, is that you sort of follow these progressions of optimization and advancement and honing a particular task, and you get to this state where you say, hey, well, the next 3 cycles or these next iterations, we can push it into this territory, and if we're there, the logical progression is blank. And so I think that's where AI almost wraps back around to being it's at the onset, I'm oh, it isn't really science fiction, and then you come and see well, this is what it could enable, and that starts to feel like science fiction. So it is really cool nonetheless.
Yeah, and like I said, that's kind of a moonshot example.
Of course, of course.
Don't send me nasty grams of oh, this is impossible, right? It's
Yep.
fun to imagine what could happen, but there's also a lot of implications there too that make it challenging. For example, I work for Keysight. We're a measurement and design company. If all of this is happening and all of these, how do I know that my device is functioning properly within a manufacturing environment or just even a design environment? How do I, what happens to DPD, digital pre-distortion? That's a pretty foundational technique that's used in our amplifier design. What happens then? And how do I design an amplifier when I don't know what the constellation or the waveform is going to look like? And it could change in very dramatically through the lifetime of that device. So there's a lot of things and challenges that we still need to think through in addition to making the AI itself work. But I think it just makes it a fun and exciting time to be a wireless engineer.
No, absolutely. Yeah. I'm so glad that I'm in the wireless space and that I like this is what we talk about on a day-to-day basis outside of doing this podcast. And so I love this stuff. It's so fascinating to see. And it's cool to really, I think, get a lens of like you know, we may not consider where AI is being deployed. I mean, something I talked about in the last episode was that I heard this commercial on my local public radio station that was talking about this like company that integrates AI into small businesses. And I was like, what the heck? Like, what does that even mean? And because I think of it exclusively in this sort of like software world, right? It's this thing that sort of just exists in data analytics or like processing algorithms and that sort of stuff. And just from that, I sort of boxed it into like, oh, that's a software world thing. I think the reality is that it's an everywhere thing, and this is a really good example of that. But it sounds like there's a big software side of this story on the wireless front too.
Yeah, absolutely. And we're already seeing a shift to more virtualized, cloudified radio access networks. It's happening today. There's large parts of the radio access network already being run on cloud infrastructure as it is today, and we're going to see that kind of extrapolate and go to the extremes in the future. So I don't think that it's out of line to predict a more hardware agnostic, software driven, software defined network going into the next iterations of 5G and into 6G.
Very cool stuff. Well, okay. Well, we'll wrap up here with I'm curious, and we kind of talked about it a bit, and I see the sort of elements trickling through of like we talked about the stadium example, and we talked about some other things, but like how does this you're the everyday person, the person who buys their iPhone without knowing how it works or what it does, like how does AI in like we see it on our side and we see how it's going to augment and help the industry. How does it help the end user? How does it help my mom when she buys her iPhone, right? Like that's what I always go back to.
I think if we do it right, she won't know that we did anything at all.
Ooh, I like that.
Right? It should just work. It should be seamless. It should help us keep the cost of the phones down. It should help us reduce the cost of running our infrastructure. It can help with us making a more sustainable ecosystem. Like all of the stuff that AI can offer. Okay, let me not say all.
Okay.
A lot of the things that AI is trying to do should hopefully be in the background where a standard everyday user has no idea that it's even happening and their stuff just works all the time.
I like that. It's funny because it doesn't feel like a particularly like wow factor thing that your stuff just works and you don't think about it. But that is the thing that like when a piece of technology like works really, really well for me, I realize it like a week later that I'm like, there was no interruption. There was no like issue. It's like, oh, that just worked. Like that was great. And so I like that's actually I think a really good way of articulating it is that like they just won't notice at all.
That's my hope.
Cool. I love it. Well, Sarah, thank you so much. It's awesome to hear how AI is currently and has the potential to keep getting deployed in the wireless space. So I really appreciate you coming on the show and thanks for talking to me.
Yeah, it's a pleasure. Hope to be back sometime soon.
Getting to hear from Sarah how AI as a tool can redefine and open up the possibilities for how we develop communications networks really brought me back to the potential that AI holds. I think it's easy for us to hear about these tech terms as buzzwords just filled with hype and potential, but forget what that potential actually translates to in an application. To me, it's pretty clear that AI has a place in the wireless network, but it's going to be an exploration to figure out exactly where it fits best. That's all for this episode of Source to Code. Next week, I'll wrap up the final episode of my AI series by talking to the one and only Jonathan Wright, Chief Technology Evangelist at Keysight. Jonathan is Mr. AI, and I'm really excited to get his perspective on the world of artificial intelligence. Now, don't forget to head on over to keysight.com/find/source to code. You can find that link in the show notes. And there you can get all the latest information on the show and read up on our guests. And please be sure to join the mailing list to stay up to date on Source to Code and what we're up to, as well as being entered for a chance to win some Source to Code swag that we'll be giving away in our season finale. And stay the most in the know by subscribing to the show in your podcast app. And if you don't mind, give us a rating. It really helps us get the decoding out to listeners and is greatly appreciated. Thanks to Sarah LaSelva for coming on the show. And as always, I'm Ben Coffin, and this has been Source to Code.